Welcome to everybody. It's Ramchandra. For the benefit of JEE Advanced students, UPSC, CSC aspirants and GATE aspirants and CSIR aspirants, in line with UPSC and JEE Advanced questions and CSIR GATE questions, I made certain questions on linear algebra. I am an IIT alumni. Even for JEE Mains, these questions are very useful. This lecture is about finding the power of a matrix. Welcome everybody. It's Ramchandra here. I am an IIT alumni and I recently started a channel called Gate Maths Concepts MRCL, and in that I had already uploaded 7 videos on linear algebra. This video is useful for all the UPSC, JEE Advanced, GATE and CSR aspirants who are looking for some challenging questions on linear algebra. I found one of the challenging questions in linear algebra is to find the power of a matrix. The power a square, a cube and up to a to the power of 4 is also not a problem. But for finding the power a to the power of 100, a to the power of 50 is definitely a problem if you don't follow a perfect procedure how to get the values. We can't just go on multiplying 100 times a 3 by 3 matrix and getting the value. Then I'll hereby give the tricks and tips how to solve a to the power of 100 3 by 3 matrix and how to get the answer in seconds. It will be very, very useful, and a question like this, a to the power of 14, was given in CSC, in UPSC examinations of a 3 by 3 matrix, and for a 3 by 3 matrix, a question about a to the power of 50 is given in JEE Advanced in 2016, and also I feel there may be different types of questions being asked on this. I want to give a simple, straightforward trick to find the 3 by 3 matrix powers and how to solve it at a glance, if not at a glance, within a period of less than 1 minute, maybe in seconds. Let us start. Let us take a question. It's my own made and nothing I had copied from any book. It is my own made, and I have taken a matrix called A is equal to 1 0 0 6 1 0 7 8 1. By looking at this matrix itself, you can see that the elements in the upper triangle are 0. And the principal triangle, all the elements are unity. In this particular condition, how to find out? The question is find a to the power of 100. That is the question. How to find out a to the power of 100 in this situation? We can't go, as I told you already, we can't go on multiplying the matrix 100 times by sitting in a competitive examination like Civil Services, GATE, JEE Advanced or CSIR. Now I will give a simple procedure how to solve it by solving this particular example. It's made by me. Let us solve. Solution. What is A? A is equal to 1 0 0 6 1 0 7 8 1. What will be A square? 1 0 0 6 1 0 7 8 1 into 1 0 0 6 1 0 7 8 1. That is equal to 1 0 0 12 1 0 62 16 1. I think you are all aware of finding the product of a matrix. Now let's go for A cube. A cube is nothing but A square into A. A square is 1 0 0 12 1 0 62 16 1 into what is A? 1 0 0 6 1 0 7 8 1. Then what will be the value of A cube? 1 0 0 18 1 0 165 24 1. In this whole process, finding a square and a cube from A is not very difficult. It can be done in few seconds, as we have done so by observing this matrix. I am going little slow. Please bear with me. Please try to understand the concept of it. Don't jump to the answer. Answer is not important here. Concept and how to do it is more important. Procedure is more important. You just see. What is the value of the second element of the first row? 6. In A square, what its value? It is 12. In A cube, what is its value? It is 18. Then can we write? Let us see. A to the power of n is equal to 100 6n. I am talking about only one element. Second element of the first column, 6n. If n is equal to 1, it is 6, n is equal to 2, it is 12, n is equal to 3, 18. Then this 1 will be 1, it is as it is, 0 is as it is. Now, the crucial part, I will call it as yn. This I am not finding now. I will give the procedure. This is what is the crucial part, the third element of the first column. Now, let us go for the third element of the second column. In second column, third element, what is the value? If you see, it is 7 in the original matrix. Not 7, sorry. It is 8 in the original matrix. For A square, it is 16. For A cube, it is 24. That means, can I write it as 8n here? Instead of, for A to the power of n, it can be 8n. Then, 1 as it is, I have taken. Now, in the power matrix of this type, where upper triangular elements are all 0 and the eigenvalues of the matrix are unity, or the elements of the principal diagonal is equal to 1, and it's a non-singular matrix where determinant is equal to product of the eigenvalues, that is product of the elements in the principal diagonal, that is equal to 1. Under these conditions, we assumed that A to the power of n is equal to 100, and for second element of the first column multiplied by n, 10, and the third element of the first column is not yet found. We'll find it. And it is 8 into n, the third element of the second row. Now, from this, how to find? Now, question is finding yn. Here, let me say y1 is equal to the third element of the first column is 7. y2 is equal to, what is y2? 62. y3 is equal to 165. This 7, 62, 165, are they following any series? Let us find out. What is the difference between 7 and 62? It is 55. What is the difference between 62 and 165? It is 103. Then what is the difference between 55 and 103? 48. And if we add another 48 here, what happens? The difference will be 151. Next element will be 316. Now, what will be the equation of this series? It's a series. So please recollect your knowledge from series. It's a series, but it's not a linear series. It's a series polynomial. It's a polynomial series. In this case, what to do? Because I am explaining the concepts, I am going slow. You need not go slow. The procedure is very simple and straightforward. In polynomial series, let us say yn is equal to, let us say y is equal to a into n square plus bn. Let that series be like this. n is from 1 to infinity. Let it be 100. We are not worried. Then y1 is equal to how much? y1 is equal to 7. 7 is equal to a into 1 square plus b into 1 plus c. That implies a plus b plus c is equal to 7. This is one equation I have got from the value of y2, y1, and y2 is equal to 62. It is 62 is equal to a into 2 square plus b into 2 plus c. That implies 4a plus 2b plus c is equal to 62. This is the second equation. Then what is y3? y3 is equal to 165. 165 is equal to a into 3 square plus b into 3 plus c. That implies 9a plus 3b plus c is equal to 165. There are three equations and three unknowns. It's a solvable. These simultaneous equations are solvable for a, b, c. And what will be the value of a? You please solve it. What will be the value of a? From 1 and 2, what it is? A plus b plus c is equal to 7. 4a plus 2b plus c is equal to 62. Then if I make this minus minus, I will get 3a plus b is equal to 55. Do you agree? This is the fourth equation. And similarly, by solving, by applying the same rule, a plus b plus c you deduct from here 9a plus 9a plus 3b plus c is equal to 165. Then a plus b plus c is equal to 7. You deduct minus minus minus. The cc will go off. Then 9a minus 8a. 3b minus is plus 2b is equal to 165 minus 7 is 158. 4a plus b is equal to, what is that? 4a plus b is equal to 158 by 2 is 79. This is the fifth equation. From 4 and 5, what we will get? A is equal to 24. B is equal to minus 17. You just see. From 5, you take out 4. Minus b will cancel. 4a minus 3a will be a. A is equal to 79 minus 55, that is equal to 24. Then place this in one of the equations, you will get b is equal to minus 17. These things, they take few seconds only. They are not very big equations are not there. Very simple equations. Then what will be the value of c? If you put it in the first, c will be 0. A plus b is 24 minus 17 is 7. 7 plus c is equal to 7, that is c is equal to 0. That means this is the solution for the above three simultaneous equations. Now what is the value of yn in my series? A into n square plus b into n plus c. That is a is 24 n square plus b is minus 17 n plus c is 0. That means 24 n square minus 17 n. This is my final yn formula. Then what will be the value of y100? 24 into 100 square minus 17 into 100, that is equal to 24,000 240,000 minus 1,700. Do you agree? This is 238,300. Now, what is the value of a to the power of 100? That is equal to what we have seen previously, 1 6 n 1 0 0 6 n 1 0, then 24 n square minus 17 n 8 n and 1, provided that n is equal to 100. This is the general value a to the power of n. Now, a to the power of 100 will be 1, 0, 0. 6 into n is equal to 600. 1 is 0. Then 24n square minus 17n, we have already calculated 238, 300. This is 800 and 1. This is the final solution for a to the power of 100. Now let us try for a to the power of 50. It will be a cakewalk. 6 into 50, 100. 24 into 50 square minus 17 into 50, 8 into 50, then 1. That is equal to 100. 6 into 50 is equal to 300, 10. 24 into 50 square, that is 50 square is 2500. 2500 into 24. 2500 into 24 is how much? 2024 into, let's calculate. What will be its value? 24 into 2500, 60,000. 60,000 minus 17 into 50, 59, 150. 8 into 50 is 400. This is 1. This is a to the power of 50. That means how easily we could find out a to the power of 100, a to the power of 500, a to the power of 50. We can go to any extent for any real number. Now, there are questions asking us in civil services also. One 3 by 3 matrix is given and we are asked to find out a to the power of 14. Find out like this. If it is a triangular matrix, if the principal diagonal elements are unity, then go ahead like this. Put n is equal to 14 for a to the power of 14. For a to the power of 50, put n is equal to 50. For example, a simple question in 2016 mathematics JEE Advanced, it was given. A matrix is given like this. Many people have given many procedures, but I feel this is the best and easiest and accurate procedure. What is a square? A square can be easily found out. 100, 810, 48, 8, 1. A cube is equal to 112, 96. It is simpler than what I have given the example question to you. You just see. Series is very simple. This is Q11. Please refer to my lectures and get maths concepts MRCL so that you can understand the development of the matrix very easily. This is Q12, Q13, Q21, Q22, Q23. These you please be very careful and you should be accurate in understanding these things. Now what is the value? Let us write a to the power of n as similarly from the above example we can take it as 4n. This we don't know, this is yn, let me call it as this as 1, this is again 4n, 0, 1. Now our challenge is to find the series of yn. What will be the value of yn? Series is 16, 48, 96. When you solve this series, as in the previous example which I have given, you will get a series like this. Yn is equal to 8n square plus 8n. Put n is equal to 1, you will get 16. When is equal to 2, you will get 48. When is equal to n is equal to 3. 8 into 9 is 72. 8 into 3 is equal to 24. 24 plus 72, 96. That means up to 3 it is correct. By induction, mathematical induction, we say it is true for yn. Then it is true for yn. What will be the value of y50? 8 into 50 square plus 8 into 50. What will be its value? 2500 into 8 is 20,000 and 8 into 50 is equal to 400. It will be 20,400. Then what is the final a to the power of 50? Final answer a to the power of 50, 100, 4n, 4 into 50 is 200. Then 1, 0. This y50 is 20,400. This is 200. This one. As I told you already, Q31, this is Q31, this is Q21, and this is Q32. From this, you can answer the question, and you can find the answer as, add these two, 20,400 plus 200 by 200, that is equal to 103. 103 is the answer. It's a very straightforward, very easy, very simple, which can be solved in seconds, provided you should know the perfect procedure. Please work out many more examples of this type and ensure that you will master this procedure and solve the equations of this type, solve the problems of this type within seconds. If you go back and see our answer, our procedure, it's a very simple procedure. A is given, principal diagonals are unit, and upper triangle, all matrix, all elements are 0. Then I have to find out only the 3 elements. For that, I have done A square and A cube, because whatever the principal diagonal will not change. The upper triangle elements are 0, hence they will not change. The only change is for 3 elements. Those 3 elements I have found out. Very easily I can find out. And once those 3 elements are found out, then I extrapolate in the series form for the yn. And I say I will find out the values of coefficients. Then I will find out the equation. That is very simple. That is 24n square minus 17n by 100 is this, a to the power of 100. There are other procedures also. For simple powers, like a to the power of 6, a to the power of 7, a to the below 10 maybe, we can go for a 3 by 3 matrix, we can go with characteristic equation. That is, characteristic equation is given, and from that we can find out the equation, and we will say a cube is so and so, so and so. In that, eigen values will come in the characteristic equation. Instead you replace the eigen value, something like a lambda cube plus b lambda square plus c lambda plus d is equal to 0. Something of this sort is the characteristic equation for a 3 by 3 matrix. Then in this, we can find out the lambda cube is equal to, we can find out lambda cube very easily, minus 1 by a into b lambda square. Replace lambda with a, then a cube is equal to minus 1 by a b a square plus c a plus d into I. From here you can find out a cube. Once you have found out the a cube, then a cube to the power of square is equal to a to the power of 6. Then if something is given like finding the a to the power of 6 means in 2 steps you can find out from characteristic equation. First you have to find out the characteristic equation, and from there you can find out. But when the problem is given like a to the power of 50, a to the power of 100, a to the power of 500, in that case, please go through this procedure and solve it. Provided the matrix is of upper triangle or lower triangular matrix. In the lower triangular matrix, upper triangular elements will be 0. In the upper triangular matrix, lower triangular elements will be 0. This procedure is applied for any triangular matrix with diagonal elements being unity. It's a non-singular matrix. And whereas characteristic equation, in this, it's applicable for every matrix. It's applicable for all non-singular matrix. Absolutely no problem. You can apply. Need not be principal diagonal, need not be unity, and it need not be a triangular matrix also. You can apply for any matrix. This is how we have to find out the power of a matrix. And if you feel this class is good for you, this lecture is good for you, please view my other videos also in my channel, Get Maths Concepts MRCL. This is my channel name. You can type this. And my lectures are GATE Engineering Mathematics by IIT Alumni. And you can see that my lectures will start from very basic to the best possible solutions to the toughest questions I have seen to solve them in seconds. Best of luck to everybody. Thanks a lot for listening to me and viewing this video. If you feel that my videos are good, please comment on my videos, view them, review them, comment on them. And also if you feel they are useful to you, please subscribe to my channel. Best of luck and thanks to everybody.